Our project name is Evaluating Machine Learning Models for Heart Stroke Prediction, a hybrid feature selection approach. Heart stroke, also known as cerebrovascular accident, it occurs when there is a disruption in blood flow to a particular part of the brain. It leads to severe consequences like serious brain damage or even death if not treated promptly. Over the last few years, stroke has become a major global issue that leads to death of a person every 4 minutes, but more than 80% of strokes can be prevented by recognizing and taking safety precautions of early heart stroke symptoms. Smoking, drinking alcohol, poor physical activities, obesity, high cholesterol, poor food habits are key factors that increase risk of heart stroke. Whereas reducing stress, anxiety, and forming habits of higher physical activities along with good food habits can drastically decrease the risk of heart stroke. Machine learning has emerged as a valuable tool in healthcare to predict and analyze heart stroke by analyzing large datasets, and recent advancements in machine learning such as deep learning and neural networks have expanded the potential to increase accuracy for stroke prediction. Many researchers and scholars and used machine learning techniques such as classification techniques to build models for early detection of heart stroke diseases and heart related diseases, which can save the lives of millions of people. Effective usage of feature selection techniques is proved to achieve higher positive results. Thus, the current research work examines the disease prediction using various machine learning algorithms. As the machine learning algorithms consumes high computational time, the current research extends it to feature selection techniques. Performance of different algorithms in different set of features are summarized. The main contribution of a project is we introduced a hybrid feature selection approach combining PCA and low variance filter to identify critical stroke prediction features, demonstrated superior performance with random forest achieving 96.68% accuracy using smooth balancing. We also evaluated our models with five different ML algorithms with varying PCA components with n equal to 5, 7, and 9 to determine optimal feature dimensions. Our main objective is to find a reliable and accurate algorithm using a hybrid version of feature selection techniques, dataset collection, data preprocessing, different feature selection techniques, balancing the imbalances of the dataset, model training, and performance evaluation are the main parts of the work. Coming to the data preprocessing steps, in this phase, we identified many null values in the dataset, which may result in reduction in accuracy. This problem has been overcome by using a decision tree classifier. Initially, the dataset is trained by using a decision tree classifier, and later the null values are replaced by using the trained classifier. ID column is also been removed from the dataset because it does not have any kind of impact on the model. Coming to the workflow of a methodology, first we have taken the dataset from the Kaggle website, and then we have done the data pre-processing steps, and we fill the missing values with the decision tree, and we have done the data balancing using the SMOT and feature selection by combining the low variance filter and the PCA, and then we have applied the machine learning algorithms, and then we have done the comparative analysis. And coming to the workflow, like we also use it capping technique for handling the outliers. Coming to the normalization part, in this phase, we use the normalization. It is a preparation technique which is used to transform the features in a dataset to a common scale. The values of numerical attributes can vary in different ranges. Hence, the features have been normalized using z-score normalization. Feature encoding, the dataset has I have few categorical attributes like gender, ever married, residence type. By using label encoder, we converted these attributes to numerical values so that these are provided as inputs for our model. Correlation is the relationship between two or more variables. In this step, we employed Pearson correlation, which helped us to enhance model performance. Coming to the data balancing, the dataset is highly imbalanced in nature, so It may not predict the results in an accurate way. To overcome this, we use SMOT to balance the dataset. The stroke count differs highly, which is like 43,000 and 43,000 zeros and 700 ones. So we balanced the stroke feature using SMOT by balancing the count to 43,000 each in order to prevent bias towards the majority class. We have applied like feature selection using low variance filter. It is a feature selection technique and that removes features which are constant across all data points. Variance is calculated within the same attribute. In this dataset, a particular threshold was given to like 0.01 value. The variances below the threshold are removed, indicating that the feature has shown a low variance. Feature selection using PCA. In this step, PCA is first we need to know about PCA. PCA is a dimensionality reduction technique that reduces the number of attributes by preserving the most important attributes. PCA transforms the original features into new access to maximize the variance. After removing the low variance features, we applied PCA to the processed data to get the maximum variance, thus getting out the most important features. Five different ML algorithms were applied to find out all model performances. Coming to the results, uh, first, the dataset, coming to the workflow of the code. First, we have dataset description, which means that dataset is extracted from Kaggle. That dataset consists of 43,401 records and 12 features. The attributes of the dataset are described in the code attached with the video. The numerical attributes in the dataset are like ID, age, hypertension, heart disease, average glucose level, BMI, and stroke. The categorical attributes of the dataset are gender, ever married, work type, residence type, smoking status. There are totally 1462 null values in the BMI column and over 13292 null values in smoking status. Of They have a percentages of like 3.36 and 30.62% respectively. And we have used different evaluation metrics like accuracy, which means like it is the percentage of total correct predictions divided with total number of instances. Accuracy is calculated using equation like TP plus TN by sum of all the values like TP plus TN plus FP plus FN. Coming to the precision, it is the percentage of true positive divided by the total prediction classes. It is like calculated using the equation TP by TP plus FP. Coming to the recall, it is a percentage of true positives divided by actual positive instances. And then we all know F1 score, it is a harmonic mean of recall and precision. Coming to the results, the model was trained in different and with the different ML algorithms were applied by using KNN like dysentery, logistic regression, random forest, XGBoost. These algorithms were applied twice when only data pre-processing was done and the same data pre-processing is carried up with a hybrid feature approach of different feature selection techniques like low variance filter and PCA. The analysis of these algorithms were done before and after PCA, along with the change in the number of components of PCA. Out of all the ML algorithms, random forest classifier consistently achieved the highest accuracy across all the test conditions, maintaining high performance in all high dimensional data spaces also. Its ability to work on high dimensional data helped us to get consistent accuracy over 96%. Random Forest initially performed well with an accuracy of 97.52% with an FN score of 97.54%. Even after the PCA is applied, the performance is not much affected and performed well with 5, 7, and 9 components with accuracies 96%, 96.58%, and 96.68%. The stability is due to random forest being an assembled method. It builds multiple decision trees and selects the most important features internally. It is robust to noise and high dimensional data allowed to perform well with reduced features. The decision tree model achieved accuracy of 95.76% with an F1 score of 95.8 initially. After applying PCA, performance remained stable with slight drop with 5 components. It achieved 93.96% and with 7 components it achieved accuracy of 94.01% and with 9 components it achieved like around 93.96%. The reason is decision tree are less sensitive to irrelevant features. So PCA helps the model focus on the most important features. This leads the model to give stable performance with improved efficiency. Coming to the KNN initially achieved like 92.36% of accuracy and FN score of 92.33%. But after PCA performance dropped slightly to 91.75% and 91.93% for 5 and 7 components, indicating the loss of key features or information for distance computation. However, with 9 components, accuracy increased to 92.36%, which indicates when we retain more feature dimension, KNN performs better. Coming to the logistic regression, initially it also performed well with accuracy of 83.43% and FN score of 83.59%. However, the performance dropped slightly with PCA for 5 and 7 components. It achieved accuracies of 77% and 79%. But while using with 9 components, it increased it to 83.17%. The reason is logistic regression struggles with reduced features, as fewer dimensions can lead to suboptimal decision boundaries. But when we retain a larger feature set, it helps model to restore its predictive power. Coming to the time complexity analysis, before feature selection, the complexity was around order of nm. Smoot took order of n square. The training model has taken a complexity of order of nm log n, and other machine learning algorithms have also shown order of k into nm. The time complexity after the hybrid feature selection was applied, it went up to order of n into p square plus p cube, and also order of n p into log n for model training and for the ML methods. In this case, n stands for the number of samples, m for the number of features, and p denotes the reduced number of features. While feature selection techniques are effective for high dimensional data, training models directly appear to be better for low dimensional data when certain reprocessing methods are implemented.